Welcome back. Today I'm going to show you how I trend my spindle to my new extruded aluminum table. If you're curious on how I assemble my new table, you can click on the link in the upper right hand corner or via the link in the description. Please be sure to subscribe if you're interested in more content like this, and now let me show you how to get started. So I bought this easy and accurate tool by Edge Technologies. It's called the Pro Tram, and this tool helped me square up my spindle to my table. Now there are very similar tools on the market, and there are other DIY options out there. You don't have to go with this one, but I did put a link in the description if you're curious on looking into more details. So in the packaging, it also comes with a little magnet to get you started on defining a origin height. So once I installed the tramming tool, I adjusted the dial indicators to 0. This lets me know that the dial is on the topmost point. And the magnet here helps define a good starting point to define a height origin between the two gauges. The little knob on the top just serves as a locking mechanism to adjust and set the dial origin. I turn the dials to the left and I want to work with the Y-axis first, and then start squaring the X-axis. Then I start lowering the spindle onto my piece of stock here, just a piece of Delrin that I had laying around. So I lowered the Z height to 10,000ths of an inch with the magnet in place, as good as I can. Once I hit my mark, I set that as my 0. Then I do the same on the other dial. Now I'm ready to test the squareness of the Y-axis. So I lower the Z up until I see the dial indicators reaching to 0 again. It's okay if your gauges look a little off, because not all of them are adjusted equally. And I'll slowly lower the Z and make sure it's square on 0, and then I'll tighten this up. It just so happened I was lucky on the first try. After tramming the X-axis, you may need to adjust the Y-axis again. To get started on the X-axis, I needed to loosen the Spindle Adapter, so I had to bring the spindle all the way up front and lower the Z carrier so I can get access to the bolts to loosen the Spindle Adapter. And you need to make sure you lower this carefully, you don't want the spindle to go off track. And here you want to make sure you loosen the bolt ever so slightly, still keeping a little bit of tension on the adapter. Now bring the spindle back to the X-axis origin. Now lower your spindle just as you did before. Try to adjust and align the height to 0. If you loosen your adapter correctly, it will be a little stiff to correctly adjust it. Then take a wrench to slightly tap on either side of the adapter to square up the dial indicators. Now that you squared your X-axis as close as you can to 0, bring the spindle back forward to the front. tighten out the adapter bolts. Now bringing your spindle back to the center, you want to double check the y-axis again, just in case it moved when you're adjusting the spindle adapter. Well, with my luck, I had to square this up, so I loosened the bolts on the XRail. Then I used clamps to twist it into position and try to square it up as best as I could. Everything looked good, so then I tightened up all the bolts. Now let's try to cut a piece of aluminum stock to see how we did without tramming. For my end mill, I'm using the Amana Spectra coated single flute. To face the stock, running the spindle at 16,000 RPM at 35 inches per minute, half a millimeter depth of cut, and 65% step over. And it seemed like with this setting it was having a little bit of a hard time. Next I tried milling 3 pockets, one with the same setting, and then one with a faster spindle speed and revving speed, and then cranking up the spindle speed with a shallower depth of cut. Here, take a listen. Of the 3 settings, I feel setting the spindle at 20,000 RPM and running 50 inches per minute, 0.1016mm depth of cut, or 4 thousandths of an inch depth of cut. Even though this is a shallower depth of cut, it doesn't put too much stress on the end mill and it prolongs the life of the end mill. I'd really appreciate it if you made it this far in the video. Please give me a like and subscribe to my channel if you haven't already. Comment below if you want to see more aluminum milling, and let me know what you thought of this one. If you're interested in more content like this, feel free to browse my channel for more content. And I'll catch you guys in the next one. See ya.
Keep it to yourself for one.